For this week, we are going to do a little bit more regarding database, what do you call, some more advanced topics. So lecture 11 and lecture 12 contents probably will not, we're going to cover in week 12 test, okay? So you don't need to worry about it. Right, so let's go through lecture 11. This is purely for your knowledge. And week 13, we don't have any lectures, okay? So remember that. Right, so week 12, week 11. So these are the topics we are going to cover in this week. String functions, dual table, transactions, data warehousing, etc., etc. Right, so you know that when you construct the tables, we have most of the columns sometimes in some tables probably contain lots of text, right, or string data or string type of data, right? So that means essentially we need to use string functions to manipulate these data in order to produce some reports, okay? So there are lots of strings functions available. So we will learn a few of it today's lecture. Probably it will help for in future in you if you want to progress in these kind of areas or databases. Okay. So one of the string function called concat function. Sometimes we need to combine two or more strings together, right? Now concat function can combine two strings together to produce a one single string. Okay. For example, if I wanted to combine the first name column and the surname column of our table, for example, in the actor table, remember we have first name and the surnames of the actor. So if I want to combine these two in my report, I can use the concat function, something like this. Okay. So here I am using the concat function. Now usually we use the concat function in the select statement. Okay. So here I want to produce the actor numbers and actors first name and surname in combined. So I can use the concat function, something like that. So the main limitation in this function is it only joins two strings, right? But there are some other ways that we can join more than two strings together, right? So one of the easiest way to do that is using the pipe symbol or pipe operator, right? So the pipe operator is the symbol that you can see here. It's just above the enter key, right? You can see kind of a small straight line there. So using the pipe operator, this is how we use to combine the strings. So in this case, again, I am combining the first name and the last name or the surname columns of our actor table. But in this case, I actually wanted to keep a kind of a single space in between the first name and the last name or the surname. So this is how I use the pipe symbol. So I use the first name column, the first name, and then two pipe symbols, and then I use a space. This is how I show it. I show the space. Okay. Use single quotes, two single quotes, and then again two pipe symbols and the second column, right? So the output now looks like here, like this. So it's more meaningful than the first one. Okay. So that is about the pipe symbol. And then the next one is called the substring function, right? Now substring function, now sometimes we need to extract portion of the string in certain columns, right? For example, in this case, I have a column called title column. I need to extract actually 10 characters from the title column. So how am I going to extract 10 characters in my title column? So I can use a substring function. Okay, so this is how I use a substring function. So again, the substring function use with the select statement. So here I use a substring function, something like this. So select substring. I use it for the title column. Now here you can see the two numbers separated by the comma. The first number says the position of the text to extract, right? For example, the position I want to extract from the first position. So I start from the first position. I want to extract 10 characters, right? So you can see here we have 10 characters extracted in my title column. So 1, 2, now remember the space. If I have a single space, it's another character, okay? So 10 characters. So like that, likewise, I can use a substring function. So second example here, again, I'm using a substring function. But in this case, now see here I'm producing a report. I wanted to extract the first letter of the first name to show the initial. Okay, so Angelina Jolie, I just put A using the substring, right? So I'm extracting a one single character starting from first position in the first name column, right? And then I combine it with the surname column with a space in between. Okay, so that is how I use the substring. Now these are very powerful, very useful string operators we regularly use in the industry. Another example, so I can actually use substring function, and then I can use the order by clause as well in order to order the way it appears. So here I order it by according to the second column order. The second column is the column that represented in the substring. And also I can order it according to uh, the column name order. So if I can specify any column name, so in this case you can see the second column which it produces actually contains two columns, right? First name and the surname, right? So this initial coming from the first name column anyway. So in this case, I use the name of the column in order to show, in order to arrange it accordingly. Okay. Uh, Sorry, did you have a question? I just saw it. Regarding the test, if we got 48% marks, then we need to do the second test, or our lab submission helps us. Probably the 48% mark, I would actually consider the lab submissions, right? So if you're behind the 2 marks, or even 3 marks, say 47 to 49, I will actually consider your lab submission to give you a pass, okay? Rather than requesting you to redo the test, okay? Because you know it's pointless to do again the retest for just for 3 marks. So I don't think it's more appropriate for you guys. So I'll consider the lab marks on that way, okay? So don't worry. So if you more than 3 marks, say for example 4, 5 marks, probably I actually consider 4 marks range, not but 5 marks is too much. I'll ask you to do the first test again if you behind 5 marks, okay? Between 4 to 1 marks, I will not going to ask, okay? All right, so that is about it. And then there's another question: what is the first number after entity represent? So, Moonheng, which question, which part you are asking? Is this regarding the first part or the second part of this slide? First name and the, okay, so, all right, so the number one means, you know, as I mentioned before, the substrings. Now, if I go to the previous screen, now substring extracting the number of characters, and we need to specify what is the starting position, because we may have a huge big character set in a one single column. So I need to tell the oracle which position I need to extract, right? So I just tell, okay, start from the position number 1, extract 10 characters, right? So that is what we mean by that. Okay, so I can start with position number 2 and extract 10 characters, so whatever. Okay, so this is the position number, starting position of the extraction. This makes sense now. Moving, yeah, all right. So let's go to this. So this is how we arrange. First and second example, yes, it's same, but I use the order by clause differently. Now here in this case, I use position number, right? So position number is the second position or second column order. In this case, I use the column name instead of position number. Okay, so that is the difference. Okay, because sometimes you may have several columns in your some of your reports combine several columns. So in that case, I can't use a position number. I need to refer the column name, right? So there are 2 columns involved in the second position in this case. Yeah. So I use the column name instead. Okay. All right. So so this is the theory. So this is a substring actually function looks like. So syntax. So starting position length we can actually put, and then the good thing about the substring is I can actually put even a negative value, right? So if I put the negative value as the length, what does it mean? It actually calculate from the last to the first, right? It going back, right? If you put a positive length, it going from the starting position to the right, right? So you can do that. So you can see substring function is a very powerful one. Okay. Actually, to be honest, in practice, I try to avoid these string functions. One reason is very complicated, right? So what I do is when I designing the table, I break it down the large string kind of tables into several columns rather than put everything into one single column. So it will be very much easier in that way. Callan, no, I'm not going to test this lecture and the next week lecture. No, there's nothing. Yeah. So this is just for purely for your knowledge and your interest. So I'm not going to test anything. Okay. Yeah. This is for the knowledge only. In case if you wanted to do higher studies in our faculty, right? These things are very important in databases. Okay. Sometimes database. We have other database subjects in higher education. Probably this will cover there, so it will aid for you if you cover it now. Okay, that's what I'm covering. All right, so substring function, there are a bunch of examples here. Now in this case, imagine here these examples give you the what kind of output I will get. Now imagine I wanted to extract now in this first example, this is the original string. I can actually specify the original string or the column name, right? That's perfectly okay. So here I am specifying the original string. Here the database, the word database. I want to extract 4 digits, or sorry, 4 characters starting from number 1. So starting number 1 position is D, isn't it? So then the 4 characters means 1, 2, 3, 4. So data. So likewise, the second one starting from the 5th position. So 5th position is 1, 2, 3, 4, 5. B, right? This is a starting position, right? From here, I need to extract 4 characters. So 4 characters, right, to the right. So this is the answer. Third example, starting position is 1. I want to extract 100 characters. So I don't have 100 characters in this string, but anyway, my output looks like this. Okay, the whole database string will get displayed. Right, this is very interesting, isn't it? So we have minus here. What do you mean by minus? Now here I'm going back. Yeah. So starting with the 8th position. So 8th position, I guess here 1, 2, 3, 4, 5, 6, 7, 8. Yes, here going back 4 positions, right? So going back means I need to extract 4 characters from here, okay, from 8. So that is what we mean by -4. So the answer is again the base. Now, if it not return anything, you will not get any error message, okay, but you will get a null value, right? For example, in this case, in the substring function, I am extracting 25 characters starting from 100. So here we don't have the starting from 100, isn't it? So, but we'll get a null value. We will not get any error message. So another example here, I'm using a substring. In this case, I'm using the column name. Extract 4 characters starting from number 1. So this is the original table, right? So this is the name column of that my employee table. So this is the output looks like when you execute this command. Okay, so 4 characters starting from number 1. Right, so this is something you might interested in. And then there is another string function called in-string function. Sometimes we need to actually find out what is the position of the given string, which position that particular given string located in a original string. Position, now this in-string function always return a numeric value, okay? It can be 0, it can be 2 or 3, whatever, okay? Now this is the syntax, right? How it looks like. So some examples here. So I use the same examples as before by now, but this time in string function. Right now, I wanted to find out the letter B, which position the letter B located in this string. Okay, so letter B, you can see the located in the 5th position, right? So the output of this function is number 5. Okay, so letter Z, there is no letter Z here, so I will get 0. Okay, so letter A, B. So AB actually located here, right? So the starting position of A is number 4, isn't it? So I'll get 4. Okay. So what is this? What do you mean by this? So this is, I want to extract letter A. The first letter A, the starting start from number 1. What is the position of letter A? So starting from number 1, position of letter A. Letter A means the first occurrence. Okay, what do you mean by this? For now, there are 3 occurrences of A's. So the first occurrence of A actually pointed in the 2nd position. So I will get number 2, right? Starting from now, so this is the starting position. Number 1 means the starting position. So this one again, letter A starting position is number 3. So 1, 2, 3. So if I start from here, the letter A located very next to it. So that means starting position, the 4th position. Yeah. So this A start at 4th position. Now this here there is an additional number. So what do you mean by is number? Which appearance of A I am considering? Which appearance of A I am considering, right? And starting now here again the same string. I want to extract letter A. Starting position is number 1, but I want the 3rd appearance of A. So 3rd appearance of A is here, right? This one. Okay. So 3rd appearance located in which position? 1, 2, 3, 4, 5, 6. 6 position, right? 6 position. So likewise, actually, this is a very power. You can see kind of you can extract whatever the information you want. So these string functions are very powerful functions you can use to extract information. Sometimes very headache, you know, when you go to practically in the in industry, some of the databases very headache to use the string function. You need to think about lot how you're going to extract some of the information, and which function you need to use. Okay. I really hate this to be honest, these stream functions, because it actually gave me a lot of headache when I work in the industry. You need to think a lot of different ways how you're going to extract the information. So yeah, so this is another example. So I use the in-string function again. This time I'm using the column name. Column name is the name column of our employee table. I wanted to extract. So I wanted to find out whether the letter TE is appearing in my original table, right? So if I get anything, that means I will get, if I have TE appeared, so that means the number should be greater than 0, isn't it? Right? So then I can specify what are the things I need to do, right? So here I'm testing whether I have TE. Yes, there is a one TE there, TE there. There's no TE there. There's another TE there. So so I will get 3, right? The answer is 3. Right. So this cast function is helpful because sometimes we need to convert certain data types to another type of data, right? Because sometimes the legacy databases contain numeric kind of values in a string, they store in a string way. So you need to convert these stuff into back to the numeric, right? So you can use the cast function in that way. So cast can actually convert characters to numeric, numerics to characters, even characters to date time or date type data, um, and even date type data can be convert back to the character type as well, and even date time character type data can be converted to different date time character type as well. So this is also a powerful function. I have used that in several times in some applications. So these are some few examples, very small examples. Here I am converting. Now this 1, 2, 3 is actually, now see, it's inside the quotes, single quote. So that means it's a varchar type character, varchar character. So I wanted to convert into a number type data, right? So I just use as a number, right? So my output is a numeric value 1, 2, 3. Second example, here I am calculating again a character into a date type, right? Now this is the default format for the date in Oracle, two digits date, and then the month in 3 characters followed by the hyphens, and then the year in 4 digits. Okay, so I'll get the output something like this. So the third example, converting the numeric to the varchar type data, right? So I'll get the varchar output something like this. Right, so that is about it. Now this is a small topic again. Sometimes we use, now sometimes we need to, before we use any tables, I wanted to test how my output looks like. For example, if I wanted to, now this is a very small, just a simple example. If I wanted to add 2 numbers, and I want to find out how it looks like in my output. Okay, so without, now you know that usually when you use a select statement, you must use a table, right? But for the testing purpose, how can we do that without having any table, because we haven't created any tables yet? So in the database management system, all the database management system, actually they have a table called a dummy table, right? So we have the dummy table. So dummy tables usually used for the testing purposes. Now Oracle's dummy table, they call it as a dual table. I don't know why they use this name, dual. Other database management systems like Microsoft SQL Server, they don't actually use any dummy table at all. So actually, that server is very powerful because you can even use a select statement without having table name. Actually, that's perfectly okay. MySQL Server, MySQL Server again use the name dual. So different database management system uses different names, right? Right. So in this case, for example, now let's go. Now this is how the dual table looks like. Um, um, Dual table looks like this. So we in the dual table we have one column, one row kind of table. So it's actually not relevant. So Oracle will automatically give the output based on the dual table. So it will actually not going through the dual table. What to do is it will execute the select statement as is without looking at the dual table. If you reference the dual table, it won't actually go through the dual table at all, just for the testing purpose. So this is how the dual table looks like. Right, for example, now this is how we use the dual table. Here I wanted to add two numbers. So I use select 1 plus 1 from dual, right? So if I run this, I'll get the output 2 because 1 plus 1 means 2, right? So here the second example, I wanted to find out how this string looks like when I printed it in my report. So I can again use the dual table for that testing purpose. So this is just a happy birthday with the using these by characters and how it looks like. And then here I wanted to find out how the date is looks like. So I use the cast to convert the character to the date type data, and I still use the dual to test it. So likewise, I can use the dual for any purpose, right? So use the dual, so it doesn't matter which one, which select statement, what you are going to do. If you have any processing like this or any string like this, it doesn't matter. You can still use the dual table for the testing. Even you can actually test, you can see the system date with the dual table. If you want to find out what is the system date, so you can use the dual table as well. And then you can even check who is the user currently using the database from the dual table as well. So there are the different advantages of using dual. So basically, dual table used to testing purposes. Okay, so that is what you need to keep it in mind. Right, that is about dual table. Now this is another topic actually I like to cover a little bit about it, because those who wanted to specialize in databases, this is very important. Now, one of the key aspect of designing a database is to adhere the consistency, because databases need to be consistent. You don't need to, I mean, if you create an inconsistent database, what will happen? Your queries probably produce a wrong information set for the decision makers, right? So how are you going to make sure the databases are consistent, right? What do you mean by the consistent? Consistent means you need to have the data. You can't, I mean, consistent means if you have a kind of, if you want to record some part of data, that whole data set has to be recorded in the database. You can't have partial data inside your database, isn't it? So if a particular business transaction, I use the word transaction here because now this business transaction and the transactions we actually refers in the database is quite different, right? Different meaning. But if you think about business transaction, if one transaction contains several sets of data which need to be recorded in different tables, right? So all these information has to be recorded there in order to the database to be considered as a consistent, right? Right, isn't it? For example, if a customer buys a product, so I need to update the customer table, right? then I need to update the sales table, and I need to update the stocks table, right, etc., etc. So all has to be there, updated, and to be there in order to consider it as a consistent database. So how are we going to actually implement it? Because up until now, we just writing the queries, but we don't know how the database, how we going to implement that consistency, how we want to make sure that the consistency has been implemented in the databases, right? That this is what we are going to learn now, right? Very simple example. I will use a simple example. So imagine that we have a small bank, right? So we are going to develop a small banking database. So in that banking database, we have a one table called a customer table. The customer table has three columns called customer IDs, names, and the balances, right? For example, I have the customer ID 101. I have one customer, his name is Fred. And at the moment, he got $200 as a balance, right? Now, each time when the customer do a kind of a particular transaction like depositing or withdrawing or paying something, bills, something like that, these balance need to be updated, right? For example, if Fred deposit $50, the balance has to be 250, isn't it? Now, usually in the banks or any other, most other databases and most other databases as well, you can see this balance itself will actually worthless, isn't it? So therefore, we need to keep a detailed description of the transaction or whatever the event that happened in our database, right? So in this case, we need to find out which date which date the Fed has been deposit money, what is the money involved, how much of money involved, and what kind of transaction is this. All these details need to be recorded, because one point of time the Fed can go to the bank and ask, okay, can you give me the list of transactions in my bank account, right? Or otherwise I can log into my online banking and I wanted to query the list of transactions for the past month. Okay, so that means we need to keep a kind of history in a separate account, right? So that history we keep in a say, for example, table called an event table, right? So in that event table, it records all the events associated in our accounts, right? For example, deposits, withdrawals, interest payments, etc., etc. So the event table looks like this. So we have a bunch of columns. So we have auto-generated number called event ID. So this event is 5,000, right? Event ID is 5,000. Next event ID probably 5,001, 5,002, 5,004, etc., etc. Okay, and then we have event date and the time, and the customer ID. So you can see this is a foreign key, right? So primary key refers to the foreign key here. And what kind of event, that is the event description. So this is, in this case, the customer Fred is depositing $50. So the final one is the amount associated in this event. Okay, so if you think about this particular one event, actually there are two things need to be done, right? So if this customer deposit $50, I need to update the customer account or customer entity, right? So update it, and at the same time I need to update the bank event table. Updating bank event table means I need to actually insert a row into the bank event table describing what do you mean by this increase 50 means, right? So in that way I can keep the history, right? I can keep the history. Yeah, so at one particular point of time, Fred can come and ask, okay, can you give me a detailed description of the history of my bank. So this 250, now you can see there are two accounts, right? So I have the balance in the customer account 250. That balance need to be matched with the history recorded in the bank event table, right? So in this case, you can see this particular customer, customer 101 Fred, this is the event ID, first open the account. So that is what we mean by create with the $0, and then he deposited $1,000 in 2nd of February, and then he again withdrew $500 in 14th Feb, and then again withdrew $300 in 3rd April, and then deposited 7th May $50. So at this point of time, the balance has to be 250, which uh, which actually matches with the balance in the customer table, isn't it? Uh, so what will happen if the bank updates the customer's account, or sorry, customer's balance, but if it not insert a row into the bank event table, right? So what will happen now? Do we have any consistent database? No, right? Isn't it? We don't have any consistent database. There is a one value there, that value not matching the value associated in this column, right? So that is the inconsistency. That is what we mean by the inconsistency, right? So same thing can happen the other way around. We can insert a row into the bank even, but we forgot to update the bank balance cell, right? Or the row. Then again there is inconsistency. Though either way can make an inconsistency in our database, right? So how can we make sure that this will not going to happen? Because sometimes we actually there can be certain events can be happen, right? For example, while we are doing something here, while we are inserting a entry into say into this column or this row, maybe suddenly power can be failed, our servers can be off, or teller machine can be go off, and then it will not going to send a single signal to the servers updating this one, right? So what will happen then? The inconsistency, right? So how can we make sure that there is no inconsistencies when executing SQL commands? Uh, right. So usually in this particular instance, we have to complete two things at once, right? What are these two things? We need to update, we need to run a insert statement, right? Insert statement in our bank event table, and simultaneously we had to run update statement, right? uh, in our customer table, isn't it? In order to make the consistent database, right? Now this is called the transaction in a database, because if you think about these particular two events or two aspects, it's actually linked to one particular event, right? That event triggers these two actions, right? So that is what you mean by a transaction in a database. So both has to be occur in order to transfer the database from one consistent state to another consistent state, right? So both need to be occurred or executed both. Okay. So in database sense, transaction means a logical unit of work, right? Logical unit of work. So in this case, the logical unit of work means insert statement and the update statement, right? So there can be multiple rows in multiple tables updated in certain transactions. Okay. So how can we implement this successful execution of a particular transaction? How do we let the database management knows that particular event has been successfully executed? So we can implement that using a command called commit, right? Commit. So with what we are doing here is we can write a code, a small programming code in SQL, telling the database management system, or case database management system, now start the transaction, right? Do the insert statement, execute the update statement, right? And the close the transaction, right? So when the close the transaction comes in and then it's successfully executed, so that means it's committed. So that means it's permanently recorded, that particular transaction in our tables. Okay. So we can implement that using so there is a command called commit. The other way around, if something goes wrong, for example, if we only insert a row into the event table, and if there is no update statement happen, right, we can ask the database management system, okay, please roll it back to the previous state, right? Because we don't want the half completed transactions. Okay. So we have a command called rollback. So we can inform the database management system, okay, roll it back. Okay. So every transaction means a database logical unit of work is either need to be committed or roll it back in order to make the database consistent, right? So I think, yeah. So why we have these halfly completed transaction? It can happen different way, different reasons, right? Sometimes there can be system errors, right, during the transaction processing. For example, power failure, right? Or maybe even bomb blast. Even a bomb can be blasted, and then, or sometimes accident can be happen. Bus can become crash into the ATM machine, and the transaction suddenly vanish. So that can be errors can be happen, and then fail to execute the full transaction, right? That is one reason. The other reason is that there can be a bunch of business rules in our create table statement. For example, we can have check constraints implemented, and it might be violated by one of these transactions. So that means we are not in a position to execute fully the given transaction, right? So in that case, we need to roll it back. So in these sort of situations, we are not in a position to fully execute the given transaction, right? So this is a fun example. So we are running the insert statement to the bank event table. In this case, withdrawing $75, and then the power has been failed. So we the update statement actually not executed at all. So this is updating the customer account. Remember the balance part. Balance reduced by 75, so it will not going to happen, right? So what will happen? So we need to roll it back. So how we actually going to implement that in the database? This is how we write the programming code. Now this is actually is not a complete fully SQL compliant code. It just wanted to show you how we writing the procedures in SQL language. So I can say, okay, is the transaction going to start transaction, insert into blah blah blah, and then update the customer balance. This is the update statement, and the end transaction. Okay. So between this, anything can happen, right? If the database management system not come to this position successfully, that means we need to roll it back, right? For example, that can be now in this case, customer is withdrawing $50. Now imagine we have a business rule in our customer table saying the balance of the customer cannot be passed by minimum balance can have of $20 or something like that, right? So if this person withdraws $50, and if it passes the $20 range, for example, we may have check constraint, right? and then it breaks the business rule, and then this transaction or this update statement will not going to execute, right? You know what will happen when you violate the check constraint. It will produce exception command, exception error message or exception message. So that means with this update will not going to happen. Yeah. So that means half completed transaction means we need to roll it back. So that means we need to delete this, go back into the previous state. Um, so so that is what we need to understand. When you develop the databases, you need to make sure the consistencies has been established in our databases. So both table must be updated, neither table must be or table is updated, right? So either one of these. So you can't have a halfly completed transaction. So that is one thing that you need to actually keep remember when you're developing the data. This is a very Mickey Mouse kind of example, but you will realize how complex these transactions are when it comes to real life. And then again, there are some other things to consider when you're designing the databases. Now, usually the databases, when you think about the transaction, as I mentioned before, this transaction has to be comply with these 4 properties, right? So if the transactions comply with these 4 properties, we call it as ACID properties, then actually we can assume this is very consistent database. What are these properties? These are the 4 things: atomicity, consistency, isolation, and durability. So atomicity means, what does it mean is, it says you can't actually divide the transaction into smaller parts, right? Because transaction means it's a logical unit of work. It has to be completed fully, okay? So that is what we mean by the atomicity. So we can actually implement this principle using, as I mentioned before, commit and rollback operations. Consistency, that is another property or thing that need to be displayed in the good databases. So we, as mentioned before, we need to make sure it's consistent. So we need to execute all the statements in our SQL commands without completing the half of the SQL statement, right? So that is what we mean the consistency. Again, the consistency can be implemented using the commit and the rollback operations. And then there are another 2 actually principles. Probably you will learn these things more in detail in there is a higher education. There is a subject called database system. Actually, if you're interested in that one, you will actually learn a lot of things regarding this. So what does it mean in isolation? What it means is if the transaction works correctly in isolation, in a one situation or one instance, it has to be worked in other instances as well, even if it runs multiple times. You can't generate any error messages, isn't it? If it runs successfully, it has to be run successfully in the other situations. So how can we make sure that it runs successfully in other situations? There are so many ways we can implement it. We call it locking and multi-versioning. So we learn that in this subject a little bit more in detail. And then the durability is very important as well. What we mean by the durability is once you commit the transaction, right? When you make sure that the transaction has been committed, that means you should able to, even something happened to the database, you should be able to recover the lost data, right? Recovery has to be there, right? That is what we mean by the durability, because that is the main purpose of having databases, right? We need to we should be able to recover the lost data, right? So how can we actually implement the durability thing? In the usually before the database management system write anything into the real tables, it will actually write into a log files first, and then it write to the table, original table, right? So the log files are the text files. So they keep the text files as a log file. So it's a very instant writing. So even the server has been gone down, the text files or the log entries will be there, right? Um, uh, so so from the text files or the log through the text files, they can recreate the tables again. Even the original table has been not created by the server itself, right? So that is what we mean by the durability, right? So that is the main purpose of having other databases, right? Otherwise, there is no point to have a database if you lose the information. Right, so that is something that you can keep remember. So this is just a summary what we have discussed. So I just keep this as well. Right, so the next subject in higher education, database systems, you will actually write lots of functions and procedures to represent these transactions. So you will create the transactions, and then you will execute commits and rollback statements in these transactions, and then even you are going to design some some host applications using C or VB or sometimes Python, and then interact with these databases to establish these sort of rules. So you will learn all these in this particular subject. And then there is another subject called data warehouses. Some people are really interested in summarized data, business intelligence, generating kind of data. So there is a subject called data warehousing. Probably you can think about that subject. And there are some group of people who don't like programming at all, isn't it? They like more business focused database subjects. So there is another subject. So you guys are very fortunate. There are a range of heaps of subjects we have database in higher education. There is a subject called business intelligence. So you don't actually write any SQL stuff or stored procedures or functions, anything. So what they do is they use Excel, Power BI, or whatever the language. They sucks data from databases, and then you write some, SQL. I mean, you just uh, uh, drag and drop the columns to create some reports. So that is the business intelligence. So more business focused students actually can do that subject. More IT focused students probably can think about this if you are interested in databases rather than going through more software development parts. Right, so that actually makes our discussion. Now can move to our discussions to data warehouses little bit. I'll give you kind of basic introduction why we need the data warehouses. Now, if you think about the companies, I think you may have learned this stuff in your IB subject, but I just wanted to mention again from the database point of view. So there are different users in the companies, right? There are some users for example, if you go to the Woolies or Coles, so you have daily operations, right? Staff who are working on the daily operations, operational staff. And then we have certain high level managers like business analyst or middle level managers who actually interested in more aggregated information to make decisions. So operation level staff, they just daily operational information. For example, how many chairs we require for the order number 1, 2, 3, 4 that being shipped today. So that kind of very granular level of detail, right? So top managers like more aggregated level, right? How many chairs we have shipped in last month, or how many sales of chairs increasing or decreasing over the last 3 years. Okay, so these sort of more high level detail need to be produced for the senior managers. So you can see kind of there are different part people require different types of information. So how can we cater? How can we design the databases for these sort of circumstances or these sort of compete? You can see the competing demands, isn't it? A more granular level of details for some people and more aggregated information for some other people, right? Uh, and then for example, we may have different kind of systems. So some, usually we call these daily operational systems called online transaction processing systems. So for example, sales system, purchasing systems, HR systems, etc., etc. So we can the operational staff can use these databases in this system to produce their own detailed reports, or whatever the reports wanted to analyze or record the information, etc., etc. Now if you think about these kind of transaction and processing systems, like uh, we need to do some important things, right? Because we record some information. So in that case, in transaction processing system, we establish referential integrity very much, isn't it? So we find out the primary keys, we find out the foreign keys, we validate whether the foreign keys are matching with the primary keys, right? So all sort of, and then we have a lot of check constraint and other constraint established in our create table statement. So there are a lot of validations has to be need to be done before we record any piece of information back in these systems. And then there can be lots of inner joins or outer joins, left outer joins, etc., etc. So you can see a very detail, right, when you write these SQL queries. Uh, Probably the people who work in the higher level, like managers, they don't care these sort of validated and then another important other matter is they actually very interested in historical information. They don't want what's going on today or what's going, how many units have been bought by Mr. X or Mr. Ravinder today. So they don't care how many packets of milk powder, or how many packets of noodles I bought. What they actually interested in, how many packets of noodles they have sold in past months in a cold store in say Cranbourne or in southeastern suburbs, etc., etc. So that is what. So these queries that we write for these people are required to access maybe millions or billions of rows in certain tables, right? So certain tables in our transaction processing systems. So you can see when you actually transaction processing system are designed exclusively for these operational users, right? By establishing foreign key constraints and these, all these check constraints, and put all these other validation operations, etc., etc. So if I run all these aggregated queries on top of this transaction processing system, what will happen? What will happen? It will actually slows down the whole operation, whole databases, and then it actually consumes lots of server, processing resources. So it's not practical enough to run more aggregated queries on top of our transaction processing systems. Um, so uh, uh, so therefore we need to actually store these aggregated information differently, isn't it? And then we don't need to actually we don't need to think about too much in past historical data, because it's already validated. by the transaction processing systems. So what we can do is uh, we can actually extract whatever the information we want from these transaction processing systems to some other databases, right? And then when you design these other databases to run these aggregators queries, so because we need to be careful as well, because the main reason for the aggregate now, one of the key thing about the aggregate queries is it has to be very fast, right? So if I put lots of integrity constraints or referential integrity constraints or check constraint, what will happen? It slows down the aggregate functions. So that means if I put some of the information, for example, if I put say the information contained in the 5 tables into a one table, right? Then I can successfully run the aggregate queries without having any problem because I have very less number of inner joins. I don't have inner join at all sometimes, right? But we may have a lot of redundant. That is okay. Redundancies are okay because our main purpose is to run aggregate queries as quick as possible rather than, because it need to be accessed millions or billions of rows. That is why we need another type of database called data warehouses. We call it as data warehouses. Okay, so because it's a warehouse, it records all these past historical information, but it's in a different aggregated format. Okay. Let's see. Yeah, so I will skip this because I think I have already. So in practice, if you think about the big companies like Rupert, the Rupert Models News Corporation. So he's a world leader in most of the business news. Owner of most of the top business related news agencies around the world. So imagine that he got around a lot of companies like Foxtel, 20th Century, Fox Sports, movie channels, etc., National Geographic Channel, etc., etc. If he comes tomorrow and asks, okay, good morning, folks, how did we go yesterday? Imagine that he has 20, 30 companies, and then each of these companies have different databases. And how can you answer these questions? To answer how, fortunately, he may ask actually how the profitability of this company, but we need aggregate functions, right? So other important thing that we need to remember is when you're creating data warehouses, is all these information, for example, all these past historical information coming from different types of databases, right? CRM system, sales system, manufacturing system, budgeting, finance system, HRM system, etc., etc. Because these systems can be provided by different vendors and probably will not speak to each other very well, right? Poor integrated, not integrated, sometimes not integrated at all. So when you create a data warehouse, these things actually matters. Okay, you need to think about which databases we are taking our information into the data warehouse. So unless we go through a clear process or a clear kind of steps, we are not in a position to answer the Rupert's and how we go yesterday, isn't it? Because there are a lot of things that we need to consider. Because if you think about these different databases, they may their column names can be different, because in the one database they can refer to as customer ID, and another database can call the customer ID as customer number, or another table may be called as CC code. So how do we make sure that all these actually reference to the same type of information? And similarly, the type of data we use in columns in each table, in each database, probably different. We can have varchar, to, char, etc., etc. And the meaning also different in tables, right? So all these things are very, very difficult to establish when you try to suck information from different databases. So these are the potential problems, right? Um, and then therefore what we need to do is we need to think about what data we need to extract, right? What significant data we need to, what kind of important information we need to copy from other databases to the data warehouse. um, uh, and then what we need to do is we can summarize everything, and then before it transferred to the data warehouse. So when you summarize these transactions in original tables, probably more granular information, more small minor information probably will be changed because we aggregate all these stuff together, isn't it? Because in order to increase the processing power. Um, so for example, now I have just given an example here. Say for example, if we have a kind of a department, say for example, company, if you sell the products, we import the products from China and then sell it to the local department stores. We may have a kind of a table like this, which includes the order line ID, customer. So these are the kind of data warehouse table looks like. Order line ID, customer name, etc., etc. You can see there are so many information over there, and then we can actually produce reports to include different aspects like which customer, which products, and which month. Now this is actually three-dimension type of information we are producing. Now imagine sometimes in real life, you will actually need to produce dimensions with 26 or 30 dimensions. Now we can imagine, right, the 30 dimension how it looks like. So these sort of aggregated information has to be produced in our reports. For example, now in case, say these three dimensions, if you produce into different months, imagine how much of information we need to extract from our database. So this is called actually cube in the data warehouse terms. We can produce these sort of cubes. Um, and then actually once we create this data warehouse, we can run the group by functions, so aggregate functions with the group by clause. So that is why we learn these things. Remember the group, aggregate functions we have learned: count, sum, average, so basic ones. So usually we use these aggregate functions in data warehouses, not in I mean, we use it in transaction processing system, but for the limited purposes. Okay. And then on top of that, there are so many other aggregate functions like roll up, cube, rank, etc., etc. They are called actually online analytical processing functions, right? Not online transaction processing function, online analytical processing functions. So that is about data warehouse. And then if you are interested in Excel, sometimes what we can do is we can use Excel, and there is facility in the Excel called Power BI. I don't know whether you heard it, Power BI or Power Pivot. Earlier called it Power Pivot, now called Power BI. So we can actually access the tables. We can link our databases to Excel and read these information. And then there are so many sophisticated analytical functions available in Power BI. We can actually slice and dice these information to produce. I mean, we can visualize how how the trends looks like, how what kind of different ways we can slice and dice the information. So you can produce a report something like this in Power BI. So this is actually another important thing we can actually perform. If you are interested in more business focused subjects, you can actually go heading towards this. There's nothing include, I mean, you don't need to program anything. It's just how but they will teach you how to use the Excel, and then how to grab and drop down these different information or different dimensions to produce these sort of reports to the management. This is actually another important area, probably. Even I would recommend people who are specializing in software development try to learn this. This is an important thing that you can learn, right? Right, so that is about it. So next week I will do, the next week is the last lecture that I will go into run. So I will give you some more, little bit more detail about how these things are work, and little bit more about data warehousing concepts. And remember, I'm not going to test these concepts again in your text next week test. This is purely for your information only. All right.